Hello. So for this question, it's asking for the out-of-plane vibrational mode of a trigonal planar molecule, find the irreducible representation. So I drew a molecule top down here. So this is the x-axis, this is the y-axis, and the z-axis is coming out the page towards us. This is typically an easier way to represent planar molecules, but I am going to actually draw it the other way so we can see the vibrational mode a little bit better. Okay, so let's fix this. So this is the x-axis, the y-axis is going into it, and the z-axis is up and down. Alright, so first what we want to do is they're saying the out-of-plane vibrational mode, so that means that it's going to be going along the z-axis because the plane is in the xy axis. So the ligands are going to be moving one way while the metal moves the other. So what we want to do is we want to take our symmetry operations and we want to apply them to this vibrational mode. So what that means is we're looking at not the individual arrows, we're looking at the vibrational node as a whole. So the sum total of these arrows all together, right? So we're going to make a little chart here. I'm going to erase the question now. All right. Let me this chair actually is kind of blocking me. So E operation. It stays the same. We know that much. Just pick it up, put it down, nothing changes. So the C3Z operation, that's going to be the primary axis. So we're taking this and we're spinning it so that each ligand goes to the next ligand's place. Now, if we were talking about the atoms on their own, then these would all be zeros. But we're actually talking about the collection of the arrows. So once you rotate this so that the ligands all exchange places, everything looks exactly the same. The metal is still pointing downward, the ligands are still pointing up, so that's 1. So 3C prime 2, so the prime indicates that we're not in the primary axis, right? So it's going to be along one of the ligand bonds. So we're taking this thing and we're spinning it this way. So that's going to flip all of the arrows upside down from where they are. So that's a -1. Now -1 indicates phase change. In this case, that means the arrow is flipping. Sigma H, once again, we're cutting through the plane of the molecule. So that's going to reflect these arrows so that they go the other way, and the metal goes up now. So that's another -1. S is the weird one, of course, so that S is an improper rotation where we rotate it and then we reflect it in a plane that is perpendicular to the axis of rotation. So S3 is going to be like a normal C3 operation, which just leaves everything looking exactly the same, except that we then reflect it, do a sigma H operation. So that's going to give us a -1 because for the same reason that sigma H did. And then sigma V is going to be cutting vertically through one of these bonds, and it's going to reflect them. This is going to stay in the same place. This is going to stay in the same place. These two ligands are going to switch places. But again, we're not looking at individual atoms in this case. So they're just going to switch, but still be pointing up. And so the atom will look, the vibrational mode will look exactly the same. So that's going to be 1. So now what we do is we match these numbers to the irrep that it matches, right? So we've got 1, 1, negative 1, negative 1, negative 1, 1. What I like to do is I like to find one that isn't E, and I like to start there because that way we can kind of eliminate them, right? So 3 sigma B is going to be 1. So we're going to look, let me point this here. Oh, I still want you to be able to, yeah, you can kind of see. 3 sigma B is going to be 1, so let's go to the 3 sigma B column. We're going to, let me get my red marker. We're going to mark off all of the ones that are not 1, so not this one, not this one, not this one, and not this one. So already we've eliminated most of the options. We know it's either A double prime 2 or A double prime, or A prime 1, I mean. So we have negative 1 and negative 1 for 2s3 and sigma h. So these two columns should be negative 1s. In this case, they're positive 1s. Or sorry, in this case, it's positive 1s. So now we've eliminated that. And if we look, all of the operations match in A double prime 2. We've got 1, 1, negative 1, negative 1, negative 1, 1. And we've got 1, 1, 3 negative 1s, and then 1.